Hello guys, welcome back to our channel Apna Tutors. So let's do more question related to 1 onto and bijective function. So let's start. So fifth question is, so that the signum function f from R to R given by f of x equals to 1 if x is greater than 0, 0 if x is equals to 0. Okay, there should be minus 1. Okay, here minus 1 is if x is less than 0, is neither 1 nor on 2. Why it should be minus 1 here? Because what signum function do, as the name suggests, sign. So it gives the sign of function, a sign of the element. So if I am taking x as positive, so it should give me positive sign, that is plus 1. Because if we multiply x with plus 1, then it will be plus x. And if x is negative, it should give me minus sign, that is minus 1. And if x is 0, so 0 have no sign, so it will give me 0. So we need to show it is not 1 nor on 2. This is very easy. Till I will do for you. So first, not 1. So again take what, as you can see, for every positive it is taking only one value. So take any two positive numbers. Take x1 equals to 1 and x2 equals to 2. Then f of x1 is equals to 1 is same as f of x2, but x1 not equals to x2, which gives function is not 1. I think you are cleared now with 1 definition, right? We need to find 2 points. If we have to show it is not 1, so we have to find 2 different points whose image is same, right? So we did that, so we got that it is not 1. So let's do it is not onto. Not onto. So for not onto, we need to find one point from the codomain whose pre-image does not exist. Okay, so if you see the range of this function, only 3 points involved: 1, 0 and minus 1. This is minus 1. Okay, it got erased. Okay, so only 3 points involved: 1, 0 and minus 1. So if I am taking other point from this, there will not exist any pre-image whose image will be that. Suppose I take y equals to 2. This belongs to R. So there does not exist any x belongs to R such that f of x equals to 2. Why? Because range of f is having only 3 elements: 1, 0 and minus 1. So that does not exist any x belongs to R such that f of x equals to 2. So our function is not onto. This was so easy. So let's move quickly to the next question. So next question is, let a equals to 1, 2, 3, b equals to 4, 5, 6, 7, and f is given some function. It is defined something like this: 1, 2, 3. This is our domain. And this is our codomain: 4, 5, 6, 7. 1 is mapped to 4, 2 is mapped to 5, 3 is mapped to 6. This is a function f. We need to show it is 1. You can clearly see it is 1. Why? Because every element from the codomain have only one pre-image. Like 4 have only one pre-image 1, 5 have only one pre-image 2, and 6 have only one pre-image 3. So there does not exist any element whose there exists 2 pre-image. So it is 1. But still, let's show it algebraically. So how we show algebraically? Suppose let x1, x2 belongs to domain. That is, our domain is here A. Let x1, x2 belongs to A, such that I had shown you how to find function is 1 or not. So take f of x1 equals to f of x2. This will give what chances that f of x1 will be equals to f of x2. In the range of function, there are only 3 elements: 4, 5 and 6. So either f of x1 equals to f of x2 will be 4 or 5 or 6. This will imply what should be x1 and x2 then. If I am taking f of x1 equals to f of x2 equals to 4, then what should be x1 and x2? It only chance is x1 and x2 to be equals to 1. Then x1 equals to x2 should be 1, because there are no other chance. Because if I am taking x1 equals to 1, x2 equals to 2, then f of x1 will be 4, but f of x2 equals to 5, which will contradict that we have taken that f of x1 equals to f of x2. Thus x1 should be equals to x2 should be equals to 1, and if I am taking f of x1 equals to f of x2 equals to 5, then x1 equals to x2 should be 2, and similarly x1 and x2 should be 3. I am taking, if I am taking f of x1 equals to f of x2 equals to 6, so I should write respectively. So are we done? Because we are always getting, when we are taking f of x1 equals to f of x2, we are getting x1 equals to x2. This shows that f is 1 1. So we are done with this question. Let's move to next question. So what is next question? In each of the following case, state whether the function is 1 1, onto, or bijective. So let's do first question. So you can see it is a linear function. If you can try to draw the graph of this function, I will give first intuition why it will 1 1 or onto, something like that. How will you see 1 1 and onto graphically? So let's put this function in graphically. So y is equals to 3 minus 4x. So if I take x equals to 0, y should be 3. That is 0 comma 3. And when I take y equals to 0, x should be 3 by 4. Something 3 by 4. So this is, sorry. Sorry for the bad drawing. So this is the graph of our function. Okay. So how will we say that the function is 1 1? When every point have only, or else every point in codomain have only one pre-image. That is, whatever you point take from the range, that means the function range where it is covering, any point you take from that. Suppose I am taking this point. So there should exist only one pre-image for which this should be the function value. So for this, only this is the value for which function is this. In short, if you want to find graphically, you should put the horizontal lines. That horizontal line should intersect the function graph only once. That is, one horizontal line should intersect every function, that function should only once. Why? Suppose if it is intersecting 2, suppose graph is like this. This is very well known graph. X square, even in this second question, function is 1 plus x square. So this is the ideal graph. This will be shifted. If I am taking f of x equals to 1 plus x square, it will be shifted by 1. Okay. So here, if I take a horizontal line like this, so there are 2 points for which I am getting y equals to this point. Suppose this is some c. So, and suppose this is x1, this is x2. So x1 not equals to x2, but f of x1 equals to f of x2 equals to c. So this shows that this will not be onto. In short, what I am trying to say, you should plot horizontal line and should see whether it intersect only once or not. And onto is easy, like whatever point you take from y-axis, if you are getting corresponding, if you are plotting horizontal line corresponding to that point, that should intersect function value at least 1. Suppose I am taking this point, and okay, sorry, suppose I am taking this point, this line is in going infinity. Okay, so if I am taking this point and if I am plotting horizontal line corresponding to this point, it intersect at one point, right? So this function is onto. It should be valid for every such points, every points in y-axis. Okay, so this is how you look at it graphically to get some intuition. If you are doing some 1 mark question, MCQ or something, you can go in this way also. So let's do algebraically. If this question is asked in more marks, how we will do it. So first of all, let's do first. You got the idea from graphically, right? That first question, f of x equals to 3 minus 4x is 1 1 and onto both. So let's first show it is 1 1. So for 1 1, what we do? Take x1 comma x2 from R such that f of x1 equals to f of x2. What does this mean? That 3 minus 4x1 equals to 3 minus 4x2. From this, will you get x1 equals to x2? Yeah, by just simple simplification, you will get this. This shows that f is 1, 1 because we had taken arbitrary x1, x2, and we got such that f of x, we had taken arbitrary x1, x2 such that f of x1 equals to f of x2, and we got x1 equals to x2. This shows that our f is 1, 1. Also, why it is onto? Why it is onto? Let y belongs to R. What we want now? We want. I will give some first intuitive idea. What should be the x? We want some x belongs to R such that f of x equals to y. But what is f of x? 3 minus 4x equals to y. So you will get x as 3 minus 4 by y. Did you got it? If you take x as this, your work will be done. So let y belongs to R. This you don't need to write in exam. This is the rough idea how we will get this x. Take x equals to 3 minus y. Okay, 3 minus y by 4, right? By 4. Then you calculate f of x. You will get it as what? You will get it as y. You just find it, because if you will do 3 minus 4 into this quantity, you will get it y. So function is on 2. So we are done, right? We had shown it is 1, 1 on 2. So as it is 1, 1 on 2 both, which implies f is bijective. Okay, so let's do next question. In next question, it is involving some x square type, that is some parabola type of function, right? So this will, of course, it will not be 1, 1. And of course it will not be onto y, because it's taking only positive values. So how we'll do it algebraically? It is not 1, 1. So we need to find some x1, x2 which are different but their image is same. So take x1 equals to minus 1 and x2 equals to 1, which implies f of x1 is equals to 1 plus 1 square, which is equals to 1 plus minus 1 square, but which is f of x2, which shows that f of x1 equals to f of x2. But x1 is not equals to x2, which shows that f is not 1, 1. So we are done with showing 1, 1. Now let's show it is not onto. Not onto. So we need to find one point from the codomain whose pre-image does not exist. So take y equals to minus 1. There does not exist x such that f of x equals to y, because range of f is positive real only. Positive real union. Okay, 0 will also not involve. Positive real only, which shows that function is not onto, because we had found one point whose pre-image does not exist. Okay, so let's keep till this much for today. In next video we'll do more questions. So till that, keep practicing, work hard, have a good day.